Hello everybody, welcome to our Algebra Review 8 and 9 combined. We're going to learn how to review, I should say, factoring GCF and trinomials. So just a review, a monomial is an expression that has one term. So here's some examples of monomials. Binomials is an expression that has two terms. So here's what, I have two terms in these, and the terms are separated by addition or subtraction. And then here's an example of trinomials where we have an expression with three terms. Okay, so when we're factoring trinomials, we have three terms in our expression, and when we're finding just GCFs, we can have many expressions. So first of all, what is factoring is just basically rewriting an expression as a product of its factors, so all multiplied together. Okay, so like 21 would be, we would rewrite this as 3 times 7, and this would be factored out because there's no more numbers that could be multiplied there. In this one here, we multiplied this. This would become 3 times 9, or 2 times, go backwards. Go 2 times 9, and 9 would be 3 times 3, so 2 times 3 times 3. And then x would be x times x, and then our y would be, of course, just y. And so this would be all factored out. Those are supposed to be little dots there. Sorry about that. Okay, so that would be a factored expression. Okay, so that is what the definition of factoring is. Greatest common factors is the common factor with the greatest coefficient, so in other words, the biggest number factor, and the greatest exponent. Okay, and so we're going to talk about how to get that here. So in other words, this term right here, 6x squared y, we factor it all out, each of these terms, and then find out what's the biggest number they have in common, what's the greatest number of variables they have in common, and then that will help us find our GCF. In this case, it's 2x and y, so 2xy for that. Okay, so let's find the greatest common factor between 18x squared and 12x squared y cubed. So 18x squared is going to be, we have, again, 2 times 9, and then 9 is 3 times 3. Okay, so 2 times 3 times 3. And then we have an x and an x, and we have a y and a y. Y times y. Okay, for 12, we have 2 times 6, and then 6 is 2 times 3. So 2 times 2 is 4, times 3 is 12. And we have x times x, and then times y, times y, times y. Oops, it's a y. Okay, so now let's take a look and see what do we have in common. So we have a 2 in common, right? And that's as many 2's as we have in common. And we have a 3 in common. Okay, and then let's look and see how many x's we have in common. It looks like we have 2 x's in common, right? 2 x's. And how many y's do we have? It looks like we have 2 y's in common. Okay, so that would constitute our GCF. Okay, so here for our GCF, we would have a 2 and a 3, and an x and an x, and we would have a y and a y. So altogether, our GCF would be 6x squared y squared. And that would be our GCF, okay, between the two. Now, you don't always have to write it out like that. You can sometimes just do those mentally and just say, hey, what's my biggest number that goes into 18 and 12? That would be 6. And I have a highest power of x squared on both of these, and factor that out. And what's my y squared? My highest power that goes into y squared and y cubed would be y squared. And so you can do that mentally as well. But some people need to write these out in order to kind of figure out those GCFs. Okay? So my first step in factoring out any trinomial or binomial is always to factor out the GCF, because if you try to factor, sometimes the numbers are really big, and so factoring out a GCF is easier to go always. And so here, my 12y y cubed, here's all my factors, 2 times 2 times 3, times y times y times y. 15y squared is 5 times 3 times y times y, and then 2 times 3 times y here. And then my GCF is 3y. So then I factor out that 3y, and then inside my parentheses, if to be multiplied, would be left my 4y squared, my 5 and y, so it'd be minus 5y, and then plus my 2 left here. So this final simplification would be 3y times what's left in my parentheses. So you factor out. So when you distribute, right, when you distribute through, you should get this back again. When you factor out, you're kind of undoing the distribution. Okay. Okay, so now we're going to factor out this trinomial here. And so let's write out all of our factors here for 15. It's 3 times 5 times x times y times y. And Then we have plus, and then 10 is 2 times 5 times y times y times y, or x times x times x, excuse me, and then times y, plus 25 is 5 times 5 times x times y times y times y. Okay, and so now let's find our common factors here. We have 1, 5 in common for all of these guys. We have 1x in common for all of these guys, and we have how many y's? It looks like we have 2 y's. Nope, just 1 y, right? Just 1 y. So we have 1 y also in common all the way across here. So my GCF will be 5x, y, and it will be left inside a 3y plus 2x squared. You have 2x squared left there, plus 5y squared. Okay, and that will be my result. Okay, now let's try one where we just do it mentally. Okay, so we say, well, what's the biggest number that will go into 4, 20, and 12? Well, that will be 4. So I'm going to factor out of 4. What's my variable for x squared? X and x will be just 1x, right? It's my biggest variable between all three of them. And then y cubed, y squared, and y will just be y. So if I pull that out of this term, what's going to be left? I'm not going to have 4 divided by 4 is 1. X squared divided by x is going to leave me with 1x. And then y cubed divided by 1y. So if I take away 1y, it'll be just y squared. Okay. Plus 20 divided by 4 is 5. Because if we distribute, we're multiplying. When we're factoring out, we're dividing. Okay. And if I take away the x, I'll have no x's left. And if I take away a y, I'll have 1 y left. Plus, and then 12 divided by 4 is 3. If I take away the x and y, I will have nothing left. And that's what I'll have left here. That should be a squared there. Okay. And that's how you factor out your GCF. So now let's start talking about factoring trinomials. This is pretty simple once you get used to it, okay? So what we're going to do is we're going to take a look at this last term, our C term. And we want factors of 10, that C term, that add up to our 7, our middle term, okay? So factors of 10 that add up to that 7, and that one's going to be 5 and 2 in this case, right? So it's just going to factor to be our x plus 5, x plus 2. The beautiful thing about factoring is you always have a key. X squared plus 2x plus 5x plus 10. And there you go. X squared plus 7x plus 10. Okay? So let's take a look again on this one here. Now this time we have what are factors of 21 that add up to that middle term negative 4. Okay? So factors of negative 21, positive 21 add up to be negative 4. So it has to be positive. So this time it looks like negative times negative will give us a positive number and then a negative addition. Okay, so how about negative 7? We have that's not going to work actually, right? So I don't think this is factorable. I think this is supposed to be a negative 21. No, it's positive 21. That's right. No, I think that's supposed to be negative 21. Let's just skip that one. That one's a typo. Let's come over here. Factors of 16 add up to 10. Okay, so this should be going to go negative 8 and negative 2. Okay, so again, we have a positive factor with a negative middle term. Going to be negative 8, negative 2. Okay, so this is going to be x minus 8, x minus 2. Okay, so this positive one means it's going to either be positive times positive or negative times negative. Okay. And then down here, positive 30, and positive middle one here. I think that was a typo also. We're going to skip that one too. Okay. All right. I don't know what happened there. Okay. Actually, let's do these. Let's do these x squared minus 4x minus 21. In this case right here, this is factors of 21 that give me a negative 4. Negative 21, excuse me, that give me a negative 4. That's going to give me a negative 7 and a positive 3, right? Because negative 7 plus 3 times 3 is a negative 21. Negative 7 plus 3 is negative 4. And that's how we end up with an x minus 7, x plus 3, okay, in this case. And so whenever you have a negative n number here, that means we're going to have opposite signs because a negative times a positive is a negative, okay? All right. And then here, what if we have a number out in front of x? So over here, this is all how to factor if I don't have a number in front of x. Okay, very simple. A little more complicated if I have a number in front of x. When that happens, I have to multiply my first term times my last term, which gives me this 24x squared. And I'm going to split that, okay? I'm going to split that up to 8x. And actually, what I end up doing is just doing 2 times 12 is 24. Then I split this middle term into 8x plus 3x, okay? Right here. And so that gives me my middle term here. And then I can group these into like this. And then I factor out 2x, and I get x plus 4 here. I factor out my 3, x plus 4 here, and then I can factor out this x plus 4 factors out here, and I'm left with my 2x plus 3. That looks like a lot of craziness, so we're just going to walk through it over here, okay? So right here, we're going to take our 2 times 5 is 10, okay? Factors of 10 add up to that 11 are 10 and 1. So we're going to take this 11 right here, and we're going to make it a 10x plus 1x, okay? We're going to leave this 2x squared plus 10x plus 1x plus 5. Okay, so make it like 4 terms now. Okay, so remember when we multiply out trinomials, we have 4 terms that we had to get to this middle term. Okay, so now what we're going to do is we're going to group these first 2 terms and the last 2 terms. Okay, and we're going to factor out. We can factor out a 2 and an x. Okay, so it's like factoring out our GCF. So we're going to factor out a 2 and an x. We'll be left with x plus 5. Now here we can't really factor out anything, so we're always just going to put a 1 there if we can't factor out anything. Okay, we'll have an x plus 5. Our goal is always to have these to be exactly the same. That's what we want. We want these to be exactly the same. When those are the same, we can factor those out and take that x plus 5 right here, and then we're going to be left with our 2x. We put those in parentheses, 2x plus 1, and we're done. And again, you can always check it, right? We have our 2x squared plus the squared plus 1x plus 10x, and that should look familiar right here, right? From up here, 10x plus 1x, and then plus 5. And that should look all familiar from right up there. And we have 2x squared plus 11x plus 5. So you can always check yourself on these factoring all the time, okay? And that's how you do that. Now, special cases is difference of 2 squares. So whenever you have a perfect square here and a perfect square here, this is x squared minus 3 squared. So we have a difference of 2 squares. All you have to do is go x plus 3, x minus 3, and you're done. That's factored, okay? So that's a special case. So here we have 4x squared minus 5 squared, and then we just factor that into 4x plus 5 and 4x plus 5. Boom. Okay, so that's my difference of 2 squares. My next special case is my perfect square trinomials, and that's when we have this perfect square in the first term, and I'm going to go ahead and put this 3 back here. So 3 squared on my last term minus this one is 2 times my first term, x, and my last term back here, 3x, okay? And so notice that that's 6x in the middle. Okay, when that happens, all we have to do here is we're going to go x here, take this term, 3 here, and that's squared, sorry. And then whatever this sign is here, that's what that is, minus, and then square it. That's it. So it's x minus 3 squared, okay? Now, the reason we have to kind of check this is because this term doesn't always fit a perfect square trinomial, so we have to be careful with that. So over here we have 2x. Take the square root of that, it's 2x squared, plus, and we have this 2 times 2x times, and then over here is 5 squared, right? So times 5. So we're just going to take this and go 2x. Right there, and put that 5 there, and then this sign right here is positive, and then we are factored, and that's our perfect square trinomial, okay? So those are our special cases. Now, if we just put that all together, we always want to take our first step is looking, going, oh, we have a greatest common factor here, so I'm going to factor out a 2, because factoring right here, we'd have to go 2 times 1 times 80 is 160, and do all that craziness. But if you just factor out a 2 right here, then we end up with a nice 2x squared plus 13x plus 40, and that's so much easier to factor because now I have one of those trinomials that have a 1 in front of it. Okay, 40 here. Okay, and then factors of 40 that add up to 13 are, what is that, 8 and 5? So 8 and 5. So we're going to go 2 times x plus 8 times x plus 5. And voila, we're factored. Okay, let's look over here. Let's see if, does 12 go into 147? That's the question we have right here. So let's go 147 divided by 12. Not quite. So how about 147 divided by 4? Whoops. 147 divided by 4, because I have suspicions this might be a perfect square. So I'm going to go 147 divided by 4. Oh, shoot. 147 divided by 4. And how's that giving me that? Okay, 147. How about 147 divided by 3? There we go. 147 divided by 3 is 49. So I'm going to divide this all by 3. Okay, so it's going to be 12 divided by 3 is 4x squared. And then 147 divided by 3 is 49. I don't know why I did 4 first. So this gives me a perfect square right here. Okay, so I'm going to go 3, and this is going to be 2x plus 7 and 2x minus 7. So I start to kind of put all my factoring skills together. Okay, so you have some practice in Google Classroom. You have a worksheet, and then I will see you all in class. Bring your questions. Bye-bye.